All right, can you guys see this?
Yep.
Awesome. All right, so hello everyone. My name is Michael Birch. I've worked at Near for a little bit over a year, and I've been on the Aurora team for a couple months. I'm just going to give a quick overview about Aurora, sort of what it is, where it's been, and talk about some of the tech at a pretty high level. I'll keep it brief, but have some questions at the end if people want to ask more in-depth questions. And feel free to interrupt me as well if something doesn't make any sense. So the whole point of Aurora is to connect Near and Ethereum and benefit both ecosystems as a result. So on the Ethereum side, right, thinking about like developers coming from Ethereum and working on Aurora, what are they getting? They're getting the benefits of Near. So they get a 1 second block time, the scalability of Near, which is of course still a work in progress, but something that they're definitely going to benefit from in the future, and the low transaction fees of Near as well, like much lower than what it would be on Ethereum itself. And then on the other side, what does Near get? Near gets all of the benefits from Ethereum being, you know, a pretty well-established blockchain, right? They've got all this DeFi infrastructure with assets and liquidity that we can bridge over and make use of on the Near side. And they have an existing developer base, you know, that helps grow Near, helps push adoption when other developers are using the platform, and existing tooling as well, which is a pretty big deal when you think about, like, people are worried about, you know, smart contract audits, and people are worried about deploy processes and this sort of thing. So being able to use tools that they are already familiar with means that they can sort of get going with Near and via Aurora with as little stumbling blocks as possible, as little change as possible. And so that brings me to this final point here, which is the Ethereum compatibility. We want Aurora to be fully Ethereum compatible. So we want people to be able to just take their code as it is on Ethereum, not do any changes, and be able to deploy it on Aurora. So same bytecode, same tooling, whether it's Truffle or Hardhat, MetaMask for interacting with dApps, same interface, all that kind of stuff. So Aurora has been around not very long, technically, officially launched May 12th, but the bridge, which is one of the big technological pieces of Aurora, was launched much earlier, back in April, and then of course it's been worked on for a long time. Originally, the EVM piece of Aurora was actually going to be part of Near Core, but we sort of pivoted and decided to make it as a smart contract on top of Near instead. And there's still a few artifacts hanging around in the Near code base as a result of this pivot, but there are to-do items to eventually get rid of them. But I think this is worth pointing out, you know, for people onboarding onto the Near team, because they might be confused, like, oh, why do we have all this EVM stuff that doesn't appear to be used at all? Yes, Sandy, I see your hand is up.
Actually, yeah, I'm not a bootcamper, but I have a question.
Sure.
So, like, what does it mean that initially we wanted to have it as part of Near Core, but then we decided to have it as a smart contract, and like, how does it work and what is the difference? That's what I never understood. So, good time for me to ask the question.
Yeah, great question. So when it's part of Near Core, basically what that means is it's actually baked into the runtime itself, right? So if you think about what a smart contract looks like on Near, it's a set of WASM bytecode that gets executed by some WASM interpreter or virtual machine. And there are host functions, because WASM, right, has this external function interface that it calls out to the node itself, and the node runtime fills in these host functions. So as far as I understand it, and I wasn't working on this at the time, so this might not be exactly what the plan was, but as far as I understand it, basically the EVM commands were going to be essentially host functions, right? So you could take EVM bytecode and pass it into the runtime and say, here, run this for me and give me back the result. Whereas what we're doing now is we've actually got all of the EVM logic as WASM bytecode. So it's executing within the WASM piece of the Near runtime, whatever the WASM VM is, right? So in some sense, this is now like a Near native contract. There's nothing special about the EVM relative to any other smart contract. Whereas if it was baked into Near core, then at some level, the Near protocol itself understands what the EVM is and what it does, which introduces a lot of complexity in the protocol. And that's one of the main reasons why we didn't want to do it that way anymore.
So is the whole EVM compiled into a WASM bytecode and deployed like that?
Yep.
Oh, amazing. I didn't know that. That's
yeah,
good.
it is amazing. It's pretty impressive. Right. Any other questions about that? Cool. Okay, so we'll move on here. So the first technical piece that I want to talk about is the Rainbow Bridge. This is, like I was saying, in some ways the big technological piece of Aurora. I actually chose to wear my Rainbow Bridge shirt today. This was, some Near swag that was put out around the same time as the bridge launch. So very high level, the idea here is we have two smart contracts. We have a smart contract on Near and a smart contract on Ethereum, and they understand how to use the data from each other's blockchain, right? So on the Near side, we've got a WASM smart contract written in Rust, and it understands what to do with Ethereum block headers. And on the Ethereum side, we've got a smart contract written in Solidity, and it understands what to do with Near block headers. So the idea is that you effectively have a Ethereum node living on the Near blockchain in the form of a smart contract, and a Near node living on the Ethereum blockchain in the form of a smart contract. And so what this lets you do is when you're interacting with either blockchain, eventually, and we'll talk about the eventually in a moment, the other blockchain learns about this because of these clients. So as an example, and we'll talk about this again later on as well, if I deposit some tokens, I lock them up on the Ethereum side, say DAI or whatever, there's going to be a block that contains that transaction, and that block is eventually going to get relayed over to the Ethereum node living on the Near blockchain. And then someone later can submit a proof to Near and say, hey, look, this is a Merkle proof showing that this transaction was in this block. Please mint me some DAI on this side to correspond to the amount that got locked up. And so we're effectively transferring the tokens in this way. And the client is then able to verify that proof and say, oh, yes, I understand that this Merkle proof corresponds to this block header, which I have. And this is all a legit transaction. It does the proof of work verification as well and make sure that it's on the longest chain. But again, the high level is basically you've got Ethereum node on the Near blockchain and Near node on the Ethereum blockchain, and then some infrastructure to relay the information back and forth, and some logic that takes care of the proof of work stuff and the signature verification for proof of stake and that kind of thing. There's a couple caveats to this, which make it a little bit more complicated than this picture. One is the rate at which you actually send data back and forth, right? It becomes expensive. Imagine if you were to try to send literally every block from Near to Ethereum, every second you'd have to be sending a block, and that would be totally infeasible. So you actually only have to send one block per epoch because of details around how the Near protocol works. And then on the other side, I think it's also done in batches. There's some number of headers that get batched up into a single transaction for efficiency reasons. And so effectively what that amounts to from a user perspective is there's some latency when you try to go cross blockchain, because you have to wait for a certain number of blocks to appear before the transaction is finalized. And there's some details there around that as well, because Ethereum doesn't actually have a real notion of finalization. So there's questions of like how many blocks are good enough and so on. But I'll leave it there for now. I'll share these slides afterwards, so you can go through any of these links if you want for more details, or if you have a particular question, we can talk about it at the end. So now we'll talk about the engine. So this is a very rough sketch of what the architecture looks like. So I mentioned the EVM logic is all baked into the WASM bytecode of our contract itself. That's courtesy of this SputnikVM library. That's a library that was originally developed by Parity, and we've made some contributions to it as well, but it's basically an EVM written purely in Rust, and so we can compile it to WASM, no problem. And in fact, it's just an ordinary cargo dependency inside our Rust smart contract, which is compiling to WASM. So the engine contains this core EVM library, and then we've written some extra logic around it. That includes things like account state management and the connectors, which we'll talk about on the next slide. So all that is wrapped up in our contract, and it gets deployed on Near. So then how does this actually get interacted with by Ethereum infrastructure, right? Because remember, we want full compatibility, so we want things like MetaMask to be able to talk to it. So we have an intermediate layer here, which we're still thinking of a good name for, but for the purposes of this presentation, we'll call it proxies. In the code base, we call them relayers, but then relayers becomes kind of an overused term. So for the sake of differentiating it from the 3 other usages of relayer, we'll call it a proxy for now. But the idea is that the engine exposes some interface, right? Hopefully you guys have already seen a presentation about interacting with smart contracts on Near. So there's some interface that the engine exposes, and the proxy knows how to talk to it. But the proxy also understands the Web3 RPC, like the Geth, or I think it is actually exactly the Geth standard that we're using for Ethereum. So any of the Ethereum tooling can talk to the proxy and make requests like, oh, tell me the nonce of this account, or get me the code state of this account, or process this transaction. And the proxy understands how to take that request and translate it into the corresponding engine request, which it can submit to the Near blockchain, get the result back, and reformat it back to what the Ethereum tool is expecting. So at a very high level, that's what's happening. Obviously, there are some details here, and again, maybe I'll mostly hand wave them away. But one thing you might wonder about is, what about payment, right? Because Ethereum tooling expects payment to happen in ETH, whereas the Near transaction that actually happens expects the transaction to be denominated in Near. And so the technical solution there is the proxy actually has an account on Near, and the proxy will try to convert the ETH into Near and sort of charge it in that way. And we'll talk about that a little bit more on the next slide as well. But as of right now, anyways, we're not bothering with that complexity because we're still trying to build adoption. So for now, it's just all the transactions are actually free, and that's fine. We're willing to, fund the transactions that are happening right now because there aren't that many. And again, this is sort of the benefit of Near, right? Is that transactions are cheap anyways. So this is sort of short-term fine, and then in the long term we have a technical solution. And again, there are some links here if people want to, after the presentation, go look at and get more details. So the last thing I want to talk about is the Aurora Bridge, which is a distinction from the Rainbow Bridge based on the target of this, right? So in both cases, the bridge on the other side is Ethereum, but on the Near side, the Rainbow Bridge is actually targeting the Near base runtime, whereas the Aurora Bridge is meant to target the engine, right? We're targeting the sort of pseudo EVM runtime that exists inside this engine. So for this, we have some special code. So we have things called connectors. Connectors are basically just the logic that talks about locking and unlocking ETH or ERC20 or whatever. We still reuse a lot of the Rainbow Bridge infrastructure. So I was talking about these clients being like nodes on the other blockchains, like Near on Ethereum and Ethereum on Near, and provers to show that the transactions are finalized and correct. So we reuse all that infrastructure. We have some extra logic for the locking and unlocking. We also have some dedicated, again, we're reusing the word relayer here, but here I think it's maybe the best usage of it, because we're literally taking events from the Ethereum Solidity smart contract and we're converting them into Near transactions so that the minting process becomes automatic. You know, you send your ETH to the ETH connector on the ETH side, and automatically 10 minutes later, your Near ETH, your ETH on the Near side has appeared because the relayers automatically picked up the event, the deposit event from the smart contract, and submitted a Near transaction on your behalf. So this couple bullets summarizes that here. So we send some Ethereum to the ETH connector contract. There's a deposit event from that contract, and the relayer captures it, constructs a proof showing the event actually happened, sends that over to Near. The Near contract verifies that proof and mints the ETH on the user's account. And then I mentioned that the idea here is, you know, we want to be able to mint directly into the sort of pseudo runtime of the Aurora engine, as well as being able to mint directly onto Near accounts. So just wrapping up here, I wasn't keeping super close tabs on my time, so apologies, Sandy, if I went over. Again, I'll share these slides afterwards, but a couple resources here. Again, if people are looking for more details or want to chat about this some more, we've got some Telegram links, and that is all. So I'll happily take any questions.